Hello everyone, welcome back. Today I'm going to give you guys the cheat notes to an MOA based scope, okay? Now we're not talking about the MOA in terms of the dials on top. We're talking about the reticle that's in there. So yesterday I covered a mil dot based scope and how to use the measurements, those little lines that are in the crosshairs to do range estimation, okay? And the way that you got a mil dot based scope is that the lines will usually be numbered from like 0 where the cross is all the way up to about 10, okay, maybe 12. Okay, if you have an MOA based reticle, your lines are usually going to go from a 0 at the cross all the way up to about either 30, 35, 40. Okay, so it's a different unit of measurement. Okay, they both do the same thing. So it's kind of like using inches or centimeters. Okay, so it's just a different unit of measurement. That's all it is. So if you have an MOA based scope, right, and I think I found a more efficient way to present this, because what I did this today is I just put one cross over here on this side, right, and what I did is I'm just showing you a section of the cross here, right. I didn't bother to number, because basically you got 5 up to 35 going this way, 5 to 25 going that way. You would have numbers going this way and numbers going down. I didn't bother to put those numbers down, okay. So if you have a scope that is MOA based and looks like that, if you've got a man standing at 200 yards, okay, he's going to come up to about 33 MOA. So on your scale here, right, when you size him up at 200 yards, he's going to come up to 33 MOA, okay. Now, if you take this number, 33, and you divide it by 3.5, right, because 1 mil equals 3.5 MOA. So if you take 33 and you divide it by 3.5, you're going to come to about 10. Okay, so on the mil dot reticle, the same man at 200 yards would be standing about 10 mils tall. Okay, so 33 MOA and 10 mils tall is the same thing. Okay, that's going to be the same height. So you can take any of these numbers here, divided by 3. Now, here's the thing: we're dealing with rounded numbers here and estimates. The number is actually like 3.4 and a couple of and some change. Okay, there's a 3.4 and some other additional decimals. I just rounded it to 3.5. Likewise, all these numbers are kind of rounded, right? I didn't get into the decimals, so when you do the division, it's if you take 33 divided by 3.5, it's not going to come out to exactly 10. It'll be like 9.5 or something. Who cares? It'll be close enough, but so that you guys get the idea. Okay, so a man at 200 yards is going to be 33 MOA. A man at 300 yards is going to be 22 MOA, right? So he's going to line up with the 22 on the scale there. A man at 400 yards is going to be 16 MOA. And the man at 500 yards is going to be 13 MOA. Okay, so we got 200 yards, 33 MOA, 300 yards, 22 MOA, 400 yards, 16 MOA, 500 yards, 13 MOA. Okay, and again, if you divide that by 3.5 to convert that back to the mil dot, you're going to come up with 10, 6.5 for the 300. On the 400, you're going to come up with 5, and on the 500, you're going to come up with 4. Okay, so these numbers mean the same thing. It's just a different unit of measurement. Okay, now here's the interesting thing when we consider this. If you look at like most of the scopes that we have today, right, most of the cheaper ones, right, when you look at the Turrents, right, the Turrents a lot of times will tell you like one click will move you half an inch at 100 yards. Okay, so the way Turrents are set up on most scopes is closer to the MOA system, right? It has the half inch clicks at 100 yards just line up better with the MOA system. Okay, I don't think that that's necessarily what it's not exact. Okay, it's not like super exact. It's off by a couple of decimal places. But here's the thing: on most of the scopes that I've seen, they don't have these units of measurement. Okay, so here's the thing: if you're buying a scope, ideally, okay, you want the units of measurement on the reticle to match up to the units of measurement on the turrets. Okay, so because there's units of measurement on the turrets, there's numbers there. You want those two to match up, right? And if you're buying like a $3,000 scope, yes, absolutely, that stuff's gonna match up. If you're buying some of the budget ones, it's not necessarily gonna match up. In fact, I have a couple of I have a Lepers scope that has like a crosshair in there, so it looks like, you know, it's got, you know, it looks like it's got lines and dots in the crosshair, but they don't match up to anything, right? It doesn't match up to a mill reticle. It doesn't match up to an MOA reticle. It's you know, it's just a cheap scope made in China, and the person that designed it just came up with their own scale. Okay, you know, which is meaningless. Or the other possibility is that perhaps in China they're using a different units of measurement, and they just, you know, copied that over. I don't know, but the point is that I do have some scopes where the dots in the reticle do not match up to the mills. They don't match up to MOA. They're just not usable, other than, let's say, to do bullet drop compensation through observation, right? So I can put, you know, I can put my bullets out there. I can see, okay, how many dots do I have to adjust? So through observation, yeah, I can you know, I can use the dots, you know, by establishing a you know, an experience with that reticle. Yeah, you can use it that way, but you can't use it this way, the way we're using it here. Okay, so let's talk a little bit about the wind. Okay, wind adjustments. So and I mentioned in the video I did yesterday, I like to work off of a 10 mile per hour full value wind, because by, you know, I just memorized in my mind the 10 mile per hour numbers, and what that means is if I got a wind that's only blowing 5 miles per hour, I cut the values in half. If I have a wind that's blowing at 20 miles per hour, I double the numbers. Also, if I have a wind that's coming in diagonally, I cut the numbers in half. So working off of 10 miles per hour is very flexible for me, okay? And in case you guys didn't see the video from yesterday, the way I measure wind is I hang the wind ribbons, right? So if the wind ribbon's hanging straight down, let's see, do I have something I can use? Here you go. Let's say this is a wind ribbon, right? The wind ribbon's hanging straight down, that's 0 wind. Out here, right, if the wind's blowing the ribbon that way, that's 20 miles an hour. So I got 20 here, I got 0 here, so then you just divide. So that's 0 wind, 5, 10, 15, 20. All right, that's all that is, okay? So 20, 15, 10, 5, 0. Okay, that's how you judge your wind, and ideally you want to hang your wind ribbons someplace like in the middle of the, you know, like halfway downrange, right? Because the wind can be different where you're shooting from. It can be different where the bullet is going to end up. Ideally, you'd like to take your measurements someplace in the middle, okay? So with the 10 mile per hour winds, okay, this is for a full value using a 5.56 bullet, okay? At 100 yards, basically, if you got a 10 mile per hour wind, it'll move the bullet 1 inch. We're gonna completely ignore that, okay? So forget the 100. We're gonna forget the 100 yards. Okay, at 100 yards, the wind moving the bullet 1 inch or 2 inches, we don't care about that, okay? So at 200 yards, okay, a 10 mile per hour wind will move the bullet 6 inches, which is basically from here to the shoulder. Okay, so the same deal. At 200 yards, I don't use the mills or the MOA measurements to adjust for wind. I basically go, like, if I got a 10 mile per hour wind, I just move the center of the cross over to the shoulder. If it's 20 miles per hour, I just double that distance, okay? So again, at 200 yards, I eyeballed the wind adjustment. Okay, but at 300 yards, okay, because at 300 yards, a 10-mile-per-hour wind can move your bullet. Will move your bullet a whole foot, which is going to come over here. And now, of course, if you got a 20-mile-per-hour wind, it's going to move over. It'll double that, right? It'll move it 2 feet. So at 300 yards, 10-mile-per-hour wind, that's a 4 MOA adjustment. Okay, so if you got a full value coming in sideways, you measure that at 10 miles per hour, you move it 4 MOA. So you look on your scale over here, you find the 4, and basically, instead of putting this dot on his chest, you're gonna move it over a little bit, right? So if you're at 300, 300 is gonna be up here at the around the 25, and if I got a 4 mile per wind, I just gotta move it over a little bit over here. If it's double, let's say I judge it at 20 miles per hour. Well, instead of doing 4, I'll move it over to the 8. Okay. So same deal at 400 yards. Okay, a 10-mile-per-hour wind will move my bullet 2 feet. Okay, so 2 feet is a 4 MOA adjustment. Okay, so again, now that's for a 10-mile-per-hour wind. If it's let's say a 20-mile-per-hour wind, well, instead of 5, I do 10. Okay, so you just double that number. Okay, or if it's less, you just cut it in half, right? So at 500 yards, if I have a 10-mile-per-hour wind, that's a 7 MOA adjustment. Okay, so let's say I got my guy at 500 yards. Here's this high over here. So if I got a 10-mile-per-hour wind, I got to come over a little bit past the 5 over here. Okay, and that's where I gotta put in the center of his chest over there. Okay, so and of course, let's say I have a 20-mile-per-hour wind, then instead of using 7 MOA, I would make a 14 MOA adjustment. Okay, so one of the things we gotta be clear here is that once we get our 0, right? We get our 0. Let's say I use a 50-yard 0. Nice thing about the 50-yard 0, first 0 is at 50 yards. Your second 0 is at 200 yards. So from 0 to 200 yards, I just put the dot in the center. I'm either going to be 4 inches high, 4 inches low, or 4 inches high, 4 inches low, right? So out to 200 yards, I'm fine. It's really at 300 yards where I really start having to have holdovers and wind adjustments. Okay. So here's the thing. There's 2 ways to make your adjustments. One is to use the reticle. Okay. And right now I've been talking about using the reticle, like moving it over. The other way is to dial in your turrets, okay? And that's something that a lot of times you'll work with a spotter. He sees where your bullets hold, and he says, okay, let's say, okay, you're 10 MOA to the right, okay? So you get on top of your turret and you click it over. All right, so that's the other way. So it's usually one or the other. You're either adjusting in the reticle, which is what I do, okay, or you're using the turrets. And usually with that, you'll have like locking turrets, where you can basically get your 0, and then there's a way to reset the way it sits so that you're starting off with a 0 number, and then you're clicking back and forth, and then you can always reset back to 0. Okay, so don't get confused on that. There's 2 ways to do this. One where you're using the reticle, which is what I use because I usually do more like fast shooting. The other way is where you have a more advanced or sophisticated locking turret, where you're dialing in these adjustments into the turret. Okay, you can't do both. You're doing either one or the other. Otherwise, you're working against yourself. The thing with the locking turrets, if usually you got to test that out, because what happens is a lot of times on some of the budget scopes, basically you got to get out there, do a lot of shooting, find your 0, basically click over 10 to the right, click back 10 to click over 10 to the right, click back 10 to the right, go back 10 to the left, go up, go down, and then see, and then take a shot and see after you make all these clicks back and forth, is it going to come back to, are all those clicks going to come back to the original starting point? Okay, so that's one of the things that you gotta, if you're playing around with the turret, right, you gotta make sure that that it tracks, and that it and your clicks are all repeatable. Okay, so that's why those type of scopes are a lot more expensive, and also as you get to the edge of the range, right? So let's say it goes up so many clicks as you start getting near to the far extremes. A lot of times the scopes start to, the values start to lose, right? Those clicks start to lose. So that's one of the things that you got to test. So that's just one of the things to be aware of if you're playing around with the Turrents. You got to test it out to make sure that these values will hold, that the number of clicks that you make correspond to what's on your reticle, because it may hold, for the first 20 clicks, but it may not hold after 20 clicks. Like by the time you get to, let's say, 40 clicks or 50 clicks or whatever, it may not track this. It may, so that's one of the things that if you're going to be playing with the Turrent and making your adjustments in the Turrent, you got to make sure that it'll track all the way out. Okay, so just putting that out there. The other thing is, if you're you got to know if you got a first focal plane scope or a second focal plane scope. If you got a first focal plane scope, you can zoom in or out, and the value of these numbers will stay the same. Okay, if you got a second focal plane scope, which tends to be the cheaper one, right? For that reason, that's what most of us have. With the second focal plane scope, in order for these values in order for these numbers to hold their value, you have to be fully zoomed out. Okay, so if you're fully zoomed out, this scale is accurate. If you zoom back in, these values now, because the whole scale kind of, the size of the scale changes basically. So these numbers lose their value. Okay, so you gotta know if you got first focal plane or second focal plane. If you got first focal plane, you can zoom in and out and still use this the scale that you see here. If you got second focal plane, you gotta be completely zoomed out. Okay. Okay, so those are the cheat notes, right? The cheat notes are, because we're going to get into some calculations now. So let's just do a quick review of the cheat notes, all right? Because that's what this video is primarily about. Cheat notes at 200 yards. If you're using an MOA scale, your man's going to be 33 MOA. Okay, at 200 yards. At 300 yards, he's going to be 22 MOA. At 400 yards, he's going to be 16 MOA. At 500 yards, he's going to be 13 MOA. Okay, and then your wind adjustments for a 10 mile per hour full value crosswind with a 5.56. We're starting, starting at 300 yards. Okay, for that 10 mile per hour wind, it's 4 MOA. At 400 yards, it's going to be 5 MOA. Sorry, 400 yards is going to be 5 MOA, and at 500 yards, it's going to be 7 MOA. Okay, so let's talk about because let's say you're using something other than a man, right? To do your range estimation, right? Because here we're using a man, so that's the cheat here. But it doesn't have to be a man; it could be something else. So first, let's talk about how we calculated this. So a man, we calculate him, the average man, at about 70 inches tall. The conversion factor is 95.5. So we take the inches, multiply it by 95.5. That's the conversion factor, right? And then divide it by whatever measurement we take, right? So over here I'm using a 20, right? So at 20, I got, if I got a guy that I measure at 20 MOA, right? So it's 70 times 95.5 divided by the 20 that I measure off of my scope. That's going to give me a range of 334 yards. Okay, all right. So now, like I said, this doesn't have to be a man; it could be a door. So a commercial door, okay, which I actually measured this morning, a commercial door is 84 inches. Okay, the door on most houses is about 72 inches, but a commercial door is 84 inches. So we can use a door to do our range estimation, because all buildings are going to have a door. Okay. And they're all going to be about the same height. So 84 times 95.5, so divided by whatever height you measure it at. So in this example, I've measured it at 10. Okay, that's going to give me 802 yards. Okay, now you might ask yourself, and I mentioned this yesterday, how are you supposed to, end of the world apocalypse, you know, who's gonna have a calculator? Well, let me tell you guys. You guys see this calculator right here? This one over here is about 20 years old, right? Solar powered. It still works, okay, from 20 years ago. In fact, I've got a calculator from, because I'm 50 years old, I got a calculator from 35 years ago, right? So one of the like first solar powered ones that came out, I think there was something like $200 when they first came out. It still works, okay? So the solar powered calculators are gonna last for a very long time, okay? They'll still be there at the apocalypse, right? They're gonna last for a long time. As long as there's a sun, they're gonna work. Or as long as the air is clean enough that the sun can come down to the earth, it's gonna work, okay? Buildings. Buildings are definitely something that you can use for this range estimation, because the great thing about building is that you can look at the plans in advance, right? You know, if you're in an area where you have access to the plans, you can look at the plans. If it's a famous building, you can look that up, right? Even on a computer, or maybe, you know, in some old books, you can look up the height of famous buildings. You can look up the height of mountains, okay? So anything that is known, where the height to is known, you can use to do your range estimation. So given I'm about 200 miles from New York City, and I still got some family trapped in there that hasn't escaped yet, okay? You know, end of the world apocalypse, I gotta go to New York and get my family out that was, you know, not bright enough to get out before the end of times. So I gotta go get them out, and I'm traveling on foot, and I want to have a good assessment of, you know, how far I'm from New York City. Now, the first thing I'm going to probably see is the Empire State Building as I'm approaching New York from Pennsylvania. And at the point that I have a good idea of at what point it's going to become visible, because I drive, although, you know, I may not be I'm not going to be driving there. So anyway, Empire State Building, okay, it measures 15,000 inches tall, okay, 15,000 inches, okay. So we're going to multiply that by the conversion factor, 95.5, right, and then divide it by the height that I see it in my reticle. So for this example, I'm using 15, right? So I'm at a point where and this is about the point where the Empire State Building first becomes visible when I'm driving to New York. It's somewhere around 15 to 20, right? It's at that, you know, at about that height in the horizon, right? So I'm using 15 here. So 15,000 multiplied by the conversion factor 95.5 divided by 15 is going to give me 95,500 yards. Okay, that's in yards. So now a mile, 1 mile is 1,760 yards. So now I'm going to take the 95,500 divided by the 1760, and I come up with 54 miles. Okay, so at the point where the Empire State Building goes up to the 15 on this scale over here, I will know that I am about 54 miles away. Okay, so there it is, guys. There are the cheat notes to the MOA reticle. And again, this is the stuff I primarily wanted to make you guys aware of. And, you know, because a lot of times when you guys are thinking of MOAs, we're saying, you know, we're just thinking in terms of inches at 100 yards for the terms of accuracy, right? So, you know, if I have a grouping that's like 2 inches wide, we're gonna say, okay, we got 2 MOA. Or if it's one inch wide, you know, 1 MOA. And for a lot of people, we think that, okay, that's what MOA is, or MOA is just making the clicks on top of the, you know, no, MOA is is an entire scale over here that we can use for range estimation, okay, and also use it for wind holes and do a whole bunch of everything that we can do with a mil dot reticle. We can do with the MOA, and we can go back and forth, because if we know that 1 mil is about 3.5 MOA, we can convert from one to the other. All right, it's actually closer to 3.4 and change. But I'm just using 3.5 because I can remember that a lot easier. So I hope you guys found this video useful. Drop some comments below. I'm probably going to do another video where I just like lay out all the formulas, primarily for myself, so I have a reference in the future, because we're using inches here and yards. But what if we're using meters? You know, so I'm going to do a video where I just kind of put out all the formulas that I've been able to gather just so I have a place to go back and, you know, collect that information if I ever need to in the future, or if any of you guys need to collect that information. So look for that video coming up. I'll talk to you all soon. Hey everyone, I just reviewed the video and I realized that I forgot to tell you guys what the holdover is at these different distances, right? Because after we range our man, right, we got to basically have the proper holdover. And what I'm going to do is I'm going to start from the 500, because that's like where you definitely got to make sure you got a holdover. So at the 500, right, where your man is going to be 13 MOA high, right? He's going to come up to about here on the scale. Okay, you're gonna hold over 8 mils. Okay, so so now here's the thing. I don't have the numbers on the bottom side, so basically, pretend this is upside down. So basically, there's the 5, right? The 8's there, so you're gonna basically put that in his chest. Okay, so because I don't have the numbers, so you have to picture that a little bit. So your holdover is gonna be 8 MOA at the 500. At the 400, the holdover is going to be 4. Okay. At 300, we don't need to use the scale. Just put the dot on his face, and it's going to drop about 12 inches into into center mass. If you put the dot right over his head, and I'm using a 50-yard zero here. So 50 yards zero, you get 1 0 at 50 yards, second zero at 200 yards. So with the 200 yards, basically you just put your dot either center mass or center face, and you should either be 4 inches up, 4 inches down. You're going to get there, okay? But the main thing is the 300, 400, 500. You got to know your holdovers. For the 500, it's an 8 MOA holdover, 400, 4 MOA. At 300, it's going to be basically dot or the cross. It's going to go right over his face. Now, of course, that's going to change with your barrel length, with the height of your scope over your bore, with the type of ammunition you're using, you know, how heavy your bullet is. So you do have to, you do have to practice with that and fine tune your holdovers for what's really happening with your gun. Okay, so hope you guys enjoyed the video. We'll talk again soon.